So starting with the work of home, okay, and over the problems for the homework, and you can do this with me, stop and start me as you'd wish, but here we go. Notice that the part per million questions I'm working with are essentially the same as the part per hundred types of problems we've done, except we're using a million. And of course, reference table T has that for you. In any case, let's go with the formula first. Since I'm looking for a part per million, really good strategy to write the formula. So ppm is equal to mass of the solute, which I'm getting right from table T, over the mass of solution. Okay, so the mass of the entire solution, which we know is the solvent plus the solute. So the mass of the solution. Okay, so I have 2.3 liters of water. Okay, and I know that the density of water is 1 gram per every 1 milliliter. So 2.3 liters, get rid of liters, liters goes on the bottom, and I know that there's 1,000 milliliters for 1 liter. Okay, so this tells me I have 2,300 milliliters. Now, I know that 2,300 milliliters will become 2,300 grams because the density of water is 1 gram for every milliliter. Okay, and sometimes these problems aren't as difficult as this, but I'm just going to convert this. So clearly I have 2,300 grams. You know, and if you don't like that, what I just did there, most of the questions you'll see, they won't give you this. They'll give us, hey, I have they'll give you the grams of the water, but I'm showing you how they do that. So I have the grams of my water. All right, now I have 3 grams of this NaCl. That's my solute. Okay, what's the part per million? Well, let's put this back in. All right, they told me I have 230 grams of, I'm sorry, 2,300 grams of water. Remember, it's the mass of the solution, which is the water, the solvent, plus what we're dissolving, plus what? 3 grams of the solute. That's the total mass of the solution. And the mass of my solute is 3 grams. And that's my setup right there. Now, of course, I have to multiply that by a million. Okay, and you can put the 6 zeros in there. Or you could just write 10 to the 6th. Nice, easy way to do that. I don't think I forgot that. So that's the formula of part per million. And let's just put that in our calculator. So very simply, now that I've set this up, 3 divided by the sum of 2,300 plus 3 is so 2,303. And I'm going to times that now by a million. If you want to put 6 zeros, be very, very careful. If you want to do 10 to the 6th, if you want to use a caret key or the EE key, be my host. Okay, so I get my answer to be equal to approximately 1,300 parts per million. Okay, and I gave you 1 sig fig here, so this probably round out to 1,000 part per million. 1,000 part per millions. But no worries here. I'm not really after the sig figs. I'm after you understanding how to use the problem. Pretty simple. Let's go on to number 14. Number 14, I have potassium nitrate, KNO3, is dissolved in this many grams of water. So I'm telling you the water grams, not giving you a volume like 13. So my formula is the mass of my solute, which I don't have yet, over the mass of my entire solution. Well, I do have the mass of my water, 40,000 and 40,300 grams. I know I have to add that to the mass of my solute because it's the mass of the what? The solution. They said I have 0.023 moles of potassium nitrate, so I'm going to have to convert that to grams. And see, 0.023 moles. And I want to get rid of moles, just doing a conversion. 1 mole is how many grams? And gosh darn it, you have to be able to write chemical formulas. Potassium loves become +1. Nitrate is, what the heck is that? Polyatomic ion's -1, so it's KNO3 is the compound. So I've got to do a what? A formula mass to know, or gram formula mass to know what my converting factor is. So I've got 1K, 1 times 39. I'm getting that from the periodic tables. Atomic mass is 39. Let me just write this over. So I have, that again, so I have 1 potassium. 1 times 39 is 39. Then I have 1N, and 1 mole of potassium nitrate. I got 1 mole of nitrogen atoms. 1 times 14. The atomic mass of nitrogen is 14. Then I have 3 oxygens. I have 3 moles of oxygens and 1 mole of potassium nitrate. So 3 times 16 is 48. Add these together. 8 and 4 is 12. Okay, and what do we have here? Plus, was that 9? Yeah, my memory's fading. So 8 and 4 is 12, and 9, I have 21. Okay, and then I have 5, 6, 10, 101 grams per mole, approximately. And that goes here. Let's solve for moles. No problem. 0.023 times 101, and I get 2.3. 2.32, well, that's of course grams. Okay, that's the mass of my solute. They gave me what? The moles. I put that in here. 2.32 grams, and I put that right here too because it's the mass of my entire solution. Let's clean this up. So mass of my solute over the mass of the entire solution, which includes the solvent plus the thing you're dissolving, times, equal there, times what? 10 to the 6, or a million, whatever you like. It's the same value, 3 zeros. So 2.32 divided by the parentheses, 4,300 plus 2.32, and you probably could have done that. And then I'm going to times it by 10 to the 6th, a million, 6 zeros, and I get a value of 50, or round to 2 here, since I started with 2 here, 58 ppm. That is my answer. 58 part per million. So out of a million pieces, 58 is potassium nitrate. Okay? So that's number 14. Number 15. Again, start and stop me as you wish. Try it on your own and see what you get. But I'm going to continue on if you don't stop me. So I have, in this question, they're giving you the parts per million. Remember, ppm is equal to what? Mass of my solute over the mass of solution, that's the solvent and the solute, times 10 to the 6th, which is a million. Now, if the part per million of water is 13, in this case they're giving me the part per million, and I have the total mass of solution. How do I know that? 1.4 kilograms of solution. What's the mass of the lead? How many grams of lead? So they're looking for how much of the lead or the solute. So that's my unknown, and the ppm is 13. I'm just put in what they give me. And we have to do a little conversion here. 1.4 kilograms. Going to get rid of kilograms, so kilograms go on the bottom. And I know there's 1,000 grams. Big number goes with small unit of 1. So obviously I've got 1,400 grams of solute. Solution, sorry, because they said 1.4 kilograms of solution. So this is the mass of the solution already. It includes the water plus the lead, because they said of solution. So we'll put that 1,400 grams there. Just making sure I'm the same units. And we're going to solve for the mass of the solute. So algebraically, I'm going to bring the 1,400 up. This is just algebra. And I'll bring the 10 to the 6 down. And that has to equal the what? The mass of my solute. I just did algebra here. Mass of lead, which will be this solute. So what I did was I brought this number up. algebraically, and this was over 1, so this had to go on the other side. And that was my solution. So what I have here is I have 13 times 1400 divided by a million. And then I'm going to times that. No, I don't. Sorry. I'm just going to multiply that. And what I get as my answer, since I'm solving for grams, is 0.018 grams. So 13 part per million in 1400 grams of water means that the grams being dissolved is that small. That makes sense. 13 ppm equals that many grams in 1400 grams of water, and that's your answer. Last question. Again, start and stop me if you want. If the part per million is NAF is 356 ppm, in this case they're giving me 356 as my part per millions. They're asking for how many grams of NAF. That's my solute, so that's my unknown. In 1,000 grams of solution, this is the entire mass of the solution, so this is 1,000 grams. Notice I'm in the same units. And I'm going to times that by 10 to the 6th. Well, let's rearrange our formula. What's going to happen? Okay, this is going to go to the top, and this is going to go to the bottom. So when I rewrite this, you should be able to do this algebraically at this point. 356 times 1,000 divide by 10 to the 6th. You don't have to write that in your calculators. You put a million in if you want. Equals my x, which is the grams of NaF, or the gram mass of the solute. So let's put that in our calculator. 356 times, I can do this, 1,000 divide by a million. And I get a small number, which I expect because 356 part per million is a small value. Okay, part per million is part per million. Makes sense that the mass would be small. And I get 0.356 grams of my NaF. That is a small value. And again, part per millions are used for dilute solutions. All right. And that is all she wrote. Those are the 4 questions. If you can understand that, terrific. Hopefully you can show me that tomorrow. Okay? Thank you.